Hi, for this problem we'll be solving 3.6.1. That's the problem right there. And we have to use y to delta transformation to solve this problem. We have to find the I across the 600 ohm resistor, the I across the 320 ohm resistor, and the I across the 100 ohm resistor right there. So to just catch up on what if you guys forgot is RA, RB, RAC, RAB, RBC right there, and the transformation would look like that. We want to go from there to there. So the equations for that, I just simplified it a little bit. Not simplified it, but it made it look a little easier. So Rx would just be RA times RB plus RA times RC plus RB times RC. And let me right there. Okay, so if you get Rx, to get RAB, RAC, and RBC, it's quite similar. It's quite easy after that. Just plug it in. Rx over RC, Rx over RB, Rx over RA to get these values. And so for this problem right here, we use RA as 20 volts, RB as 100, and RC as 50. If you want to see where you see the transformation right there, 20, 50, 100 in the middle right there, I circled it for you guys. So you should go from a T to basically that. Or you can call that a Y to delta, that's what you're supposed to call it. So once you plug in those values, you get, I did this on calculator to make it a little more neat for you guys, but you get RAB equals to 160 ohms, RAC equals to 80, and RBC equals to 400 ohms. And so you redraw the circuit, and this is what it looks like right there. I called it figure 2, and then once you get that, you want to simplify it a little more, so you get the Thevenin resistance. And so you can see by here is that the 80 ohm resistor and the 320 ohm resistor is in parallel. Same with the 160 ohm resistor and the 240, and the 400 and 600 ohm resistor. If you see, they're all parallel. So if you guys forgot, the equation for a parallel resistor is just 1 over RA plus 1 over RB, and then in reverse of that, or RA times RB divided by RA plus RB. So once you plug all those values in for each one, so for 80 and 320, you would go 80 times 320 divided by 400, and then you would get 64. And then you would do the same for 400 by 600, the same for 160 and 240, and you would get this right here, this circuit right here. And for simplifying from here is quite easy. As you can see, the 64 and 240 are in series, and those two combined are in parallel with the 96 ohm resistor. And once you use the formula, so it would be 96 ohm resistor in parallel with a 304 ohm resistor, you would get the Thevenin resistance of 72.96 ohms. Now this we will use for to solve part D of the problem. Now we come over here to the next page. So we're gonna have to use the current rule. The current rule is basically, if you want the current through a resistor, you multiply the current and multiply it by the ratio of the other resistor divided by the total resistance. So you get I, which is the current through the 304 ohm resistor, which would just be, if you look over here, which would be the current through 64 and 240 combined. I labeled it IX. And so if you come over here, you apply the current rule, and the current as we were given was 1 amps. So it'd just be 1 times 96 divided by 240 plus 64 plus 90, which is just 304 plus 90, and you get 0.24, which is 240 milliamps. But that's not the current through the 600 ohm resistor here. That's the current through both of these. Because current, well, although we did find current through for both of these, current is always the same through each resistor in series. So the current is the same through the 240 as it is in 64, so we don't have to really do anything there. And so the current we got was 240 milliamps. We take it over here. 240 milliamps is actually going through the 400 ohm resistor and the 600 ohm resistor. Now we want to find out how much of each. Now for this, you do similarly, just the current rule. So it's just, you want the current through 600, so you multiply it by the ratio of 400 divided by the total, which is 1,000. And so you get 0.4 times 240 milliamps, which was the current through both of them. So then you get I0 equals to 96 milliamps, right? And then you go to I1. You want I1. I1 was the current through the 320 ohm resistor. So if you see, the 64 ohm still has the same current. We calculated 240 milliamps, right? Because 240 milliamps goes through these two resistors. So the 64 ohm resistor is actually a combination of the 320 and 80 ohm resistor in parallel. So again, you can just use the current rule, and the current rule would just be 80 divided by 400, which is just 80 divided by 320 plus 80. Multiply that by the I we calculated that goes through those two resistors, which is 0.24, and you would get 48 milliamps. So for I2, which is the current through the 100 ohm resistor, that actually gets a little not as easy. You have to use mesh current analysis. So for that, we know that the voltage from here to here equals to V2. So this resistor combined with this resistor, the voltage across these two equals to V2, which is right there. Here, let me mark that for you guys. Right there. The V2 is equivalent to the V that goes across the 100 ohm resistor, because voltage is always same in parallel. So this has the same voltage going through as these two resistors have. This resistor has the same voltage going through it as these two resistors have it. So the only thing that splits is the current here. So the current we calculated for this one was 48, and for this one it was 96, right? Because yeah, we calculated that to be 48, that by 96, because this is 96 and that's 48. So when it comes in, when it merges, this has to be 48 in order to, so you see that 48 plus 48 has to equal to 96. So we know this, the current going through the 50 ohm resistor is 48. So now all we have to do here is do the mesh current through this loop right here, right? Or the mesh current analysis, the voltage analysis in a sense. So you do 50 times the current we found through it, which is 0.048 or 48 milliamps, and 600 times 0.096 or 96 milliamps, the current we found through it. And you get that equal to V2. So V2 ends up being 60. So V2 across these two resistors have 60 volts going through them, and this resistor has 60 volts going through them. So I equals V over R. So you use that logic, and so you get I equals to V2 over 100. So 60 over 100 equals to 6.6, and that's 600 milliamps. To get the power is just IV. So if you look on over here, when we found the Thevenin resistance and the current, you could transform this, but you could always just use I square R to get power as well. So we know I is 1 and we know R is 72.96. 1 squared is 1. Multiply them together and you get 72.96 watts as your power.